Hello, my name is Chet Babler, and I'm the Vice President of the Automotive Business here at Arm. I'm really happy to have the opportunity to give this talk today. Since the start of the cognitive revolution 70,000 years ago, when Homo sapiens evolved their intelligence and ability to communicate, humankind's ambition to better itself through scientific innovation has been relentless and highly successful. We all have in our mind a view of what the future could look like and how science and technology will transform how we work, live and play. So, to start my talk, I wanted to share with you the vision of the future that I had as a child. As a young boy, growing up in the 1970s, I loved all things related to space, cars and technology. And I know I'm not alone when I share that I was fascinated by the vision of possible futures portrayed in movies and shows like Blade Runner, $6 Million Man and Knight Rider. As a child, I knew that these futuristic technologies were just science fiction, but these childhood experiences were inspirational in an enduring way. Fast forward 4 decades, and I now find myself part of the industry that has the opportunity to make this science fiction a science fact. Let me share what's exciting me today about the transformative effects of computing on our everyday lives. The power of computing has brought us closer together through instant communication. The power of computing has allowed us to enhance tasks we may not be good at. The power of computing allows us to store and then retrieve vast amounts of information instantly. And the power of computing has supercharged our ability to analyze information and make decisions. But a common theme in these examples is the fact that we're using that computing power. Thinking back to my vision of the future when I was a child, what about a world where technology thought and acted for itself? We believe that computing is undergoing its most significant paradigm shift in decades. And the new workload driving this change is autonomous decision-making. Autonomy is when the power of computing enables independent decision-making and the safe completion of tasks. Autonomy will usher in a new era of functional utility and human safety, allowing us to focus on tasks and activities that will boost our work or leisure productivity. This will not be an overnight transformation. It will be a journey, but I'm really excited because I'm seeing how through collaboration, we can make this future vision a reality and improve all our lives. There's a lot of discussion about self-driving autonomous vehicles and the likely timescales they will be deployed in. But while the timelines may be debated, we should be in no doubt that increasing levels of automation of vehicles is the future of mobility. As a society, we're dealing with challenges of urbanization, climate change, social inclusion, and the digitalization of our lives. Increasing levels of automation in vehicles and the new capabilities that come with this will absolutely be part of the solution of some of these societal imperatives. There will be challenges along the way to achieving this vision, but in the long term, the societal benefits of vehicle autonomy are just too great to ignore. And the good news is that we're not starting on this vision from zero, and we already have many of the needed technology building blocks. Advanced Driver Assistance Systems, or ADAS, are already automating aspects of human inputs for driving, including braking and steering. Features such as automatic emergency braking, lane keep assist, and adaptive cruise control are no longer limited to the premium segment and can be found in many new vehicles today. As well as the functional utility ADAS brings, with over 9 out of 10 accidents involving human error, studies have shown that ADAS could reduce accidents by up to 40% and deaths by an incredible 30%. Automating decision-making in vehicles is already making a tangible difference and saving lives today. And so going back to the vision of the fully autonomous vehicle, by further enhancing the automation capabilities of ADAS technology and applying it to operational domains where routes, speeds, location, and environmental conditions can be bounded, we can start the journey to deploying autonomous vehicles today. This is the so-called Level 4 of autonomy in vehicles. These autonomous vehicles can help to address the growing demand for last-mile delivery, enable fixed-route shuttles, and also transform road freight and ride-hail services. These are very real applications of autonomy that we will start to see commercialized soon. And the experience and learnings from these constrained autonomous deployments will prove invaluable to understanding how we might tackle the future challenge of unbounded operational domains and the ultimate of Level 5 autonomy. Arm is fully committed to enabling vehicle automation. Last year, Arm was one of the founding members of the Autonomous Vehicle Computing Consortium. The AVCC is working to define a system architecture and computing platform for the scalable deployment of automated and autonomous vehicles. Arm is also working with a wide ecosystem of automotive partners to bring together the range of technologies and capabilities needed to make vehicle automation a reality, including software, tools, and functional safety. And lastly, we're developing dedicated hardware and software technology to meet the performance, safety, and efficiency needed for autonomous compute. But I'll come back to that later. In addition to automotive, another key area where autonomous decision-making will make a huge impact is in the industrial sector. Arm-based technology is already deployed extensively in these factory and warehouse environments. We're now focusing our efforts in this segment to enable the autonomous future of the industrial sector. In the automotive world, we speak of Level 5 autonomy as the ultimate goal. In the industrial case, factory automation, industrial IoT, and mobile robotics come together to deliver smart manufacturing. But what exactly are these innovations, and what do they enable? Simply put, in smart manufacturing, autonomy provides the intelligence to customize workflows, whether that's deciding what to manufacture next or to optimize production line logistics. Factory production lines will become reconfigurable, enabling flexibility to meet the needs of differing products and their specific customizations. And this will add value and save cost. This is an incredibly powerful concept because it enables efficient use of resources and the ability to meet changing production, customization, and logistics needs. And of course, fewer but reconfigurable factories and warehouses will be better for environmental sustainability. In an industrial environment, the autonomous capability comes from distributed intelligence, a network of interconnected systems which include smart sensors, extensive data collection, and cloud connectivity. These multiple systems with differing performance requirements execute varying levels of decision-making and are coordinated and combined to enable an intelligent factory or warehouse. This distributed intelligence will provide an order of magnitude greater insight into industrial production and operations than was previously possible. So how can Arm help you with your journey to autonomy? Whether it's a vehicle, a factory environment, or another application altogether, it is clear that autonomous workloads will need fundamental building blocks that are common across use cases, and we show some here. Scalable compute is needed to address the range of processing capability for differing workloads in a power-efficient manner. Safety, combined with security and real-time response, is absolutely critical to avoid the risk of damage or potentially fatal outcomes if systems fail or are cyber-compromised. And as we move to higher levels of system complexity, information from multiple sensors, such as compute vision, will need to be combined with machine learning to derive actionable intelligence. And all of this hardware needs to be dimensioned in a holistic way to run the complex workloads needed for autonomous systems. And Arm is developing multiple technologies targeted at addressing the specific requirements of safe autonomous systems, including CPUs, GPUs, ISP, ML processors. So, wrapping up, we believe autonomy will become a predominant workload of the future, transforming multiple segments, including automotive and industrial. The hardware and software challenges will be significant, but Arm is committed to supporting its ecosystem on this journey to autonomous, and we invite you to join us too. And that child from the 1970s is super excited to both witness this amazing transformation and to be part of the industry that will make this science fiction a reality. Thank you.